Hi everybody, welcome to our week 12 lecture for Math 261. Hope you're already having a restful Thanksgiving week, but of course we've got homework due and an exam coming up, so I just wanted to talk about the law of sines and the law of cosines. Those are the last two things out of the topic 7 that we haven't covered yet. So before we do this, let's get a little bit of notation. These questions are where they ask you to solve a triangle. So what does that mean? What that means is that you find the values for all sides and all angles. And there's a little bit of notation when they give you these triangles. They're going to use capital letters for angles. Some people use Greek letters for that. So if you're looking in another book for some help, or if you're in another class that you need to do this for some reason, then you may see Greek letters instead of capital letters, but our book uses capital letters. And they usually use A, B, and C, although they don't have to. And then they use lowercase letters for sides. And the important thing is that the side that's opposite an angle has the same letter. So the side that's opposite of angle A is side A. The side that's opposite angle B is side C, and the side that's opposite angle C is side C. Now, in a right triangle, if we have an angle and any side, we can solve this with SOHCAHTOA. But SOHCAHTOA only works for right triangles. When we have a non-right triangle, we can't use SOHCAHTOA. So we're going to go back to geometry, our high school geometry, and think about the theorems that we learned for congruent triangles. We had a whole bunch of those, and here are the big ones. We had side, 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 angle, side, angle, side, angle, 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 side, and we didn't have this. We didn't have side, side, angle, but sometimes when we solve triangles, we can find a side, side, angle. So this was not from geometry, but sometimes we can use this. It wasn't in geometry because in geometry, when we wanted to find the ones where we could always find a solution. In side, side, angle, we can't always. That's called the ambiguous case, and we're going to treat that one separately. The way to remember which one is the ambiguous case is if you spell that backwards, you can see that that's not going to be a very nice word. So that's a good way to remember it. Okay. All right. So let's start with the law of sines. And let's look at these theorems. We've got side, 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 angle, side. We've got angle, side, angle, and angle, angle, side. And we've got side, side, angle. If I have side, side, well, let me tell you what the law of sines says first. It says in any triangle that if you take the sine of any angle and divide by the opposite side, that those are all equal, no matter what. So to use the law of sines, we're going to have to know an angle and an opposite side. So let's look here. If I have side, 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 I don't know any angles. So that one's no good. Can't use the law of sines in that case. If I have side, angle, side, side, angle, side, again, I don't have an angle and an opposite side, so I can't use that one. If I have angle, side, angle, angle, side, angle, I don't have an angle and an opposite side, but I can find the third angle because I know that all the angles must add to 180 degrees. So in this case, I can because I've got an angle and the opposite side. Angle, angle, side, angle, angle, side as I go around the triangle. And yes, I have an angle on the opposite side, so that one's good. And side, side, angle, side, side, angle, and again, I have an angle and an opposite side, but like I said, this is a wonky one. This is an ambiguous case, and we'll look at this one separately. Do some analysis to take a look at this. So we've got a triangle ABC, it's listed below. A is 84 degrees. B is 29 degrees. And we know that side A is 61. And we need to solve the triangle. So the first thing I want to do is see, do I know an angle and its opposite side? And sure enough, I do. Notice this is an angle, angle, side. So yeah, I know an angle and its opposite side. So this is a perfect situation for the law of sines. So I'll take the sine of the angle that I know and divide by its opposite side. That'll be the sine of B, which is 29, divided by its opposite side. And that'll be the sine of angle C divided by its opposite side. I don't know either angle C or side C, so I'm going to start with this. So I'm going to take this and I'm going to solve this for side B. So I'll cross multiply. And I'll divide by sine 84. And that's going to give me that B is equal to 61 times the sine of 29 divided by the sine of 84. And I'll just calculate that on my calculator. So calculator, where are you? Here we go. Make sure we're in degrees because they gave us everything in degrees. 61 times the sine of 29 degrees divided by the sine of 84 degrees gives me a 29.736. And they want, one decimal place, so 29.7. Okay. Now I'll go to figure out sine C. Now I could use what I did with angle with side B to do that, but I want to stick with the things that they gave me in the original problem as much as possible. I'm going to have some round off with this side B, and I don't want that round off to carry over and make my answer for side C be incorrect. And in addition to that, I really don't want to have, what else was I going to say about that? If I made a mistake on side B, I don't want it to carry over and make my side C be incorrect. So I'm going to start with what I had originally in the problem as much as possible. I'm not going to use that B. I'm just going to save it. B was 29.7. And let's see. Oh, I know the two sides, so I can find the third angle. So let me come off on the side here and go 84 plus 29 plus C equals 180. So I can find angle C really quickly. 180 minus 84 minus 29. Side C is 67 degrees. So sine of 67 divided by side C. And again, I'll cross multiply and solve. I'll skip a few steps now. It's the same algebra as what I did to find B. So I'm just doing 2 steps at once instead of doing it one at a time. And I'll take 61 times sine 67 divided by sine 84, and that's giving me 56.46. So that'll be a 56.5, and my C was 67. So let's pop that into Alex and see what good old Alex has got to say about that. 67, 29.7, and 56.5. Let's check this out. Voila. So there's our law of sines. You're going to use this when you have a side, 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 or when you have a side, angle, side. Those are the 2 situations where you don't have an angle and the opposite side. I'm going to draw a triangle here and show you the rationale behind the law of cosines. This one gets used a lot in more advanced math. I would say it gets used more than the law of sines, but that's just my experience. I could be wrong. So let's put a C and an A and a B, and opposite that A is going to be a capital A, opposite that C is a capital C, and opposite that B is an angle B. And I'm going to say suppose that this was a right triangle. If this was, which is not, but if it was, you could write a Pythagorean theorem. You could write C squared equals A squared plus B squared. Now that's not correct for this triangle because it's not a right triangle. But the law of cosines says that this is almost a right triangle. We can put in a compensating factor. So the compensating factor is to subtract off 2 times side A times side B times the cosine, since it's law of cosines, of angle C. Let's look at this now. This A in the compensating factor was one of the things that we said, well, it could be a side. This side in the compensating factor is what we treated as the other side. And the angle is what we treated as the hypotenuse. So that's the pattern. And also notice up here, we're treating A and B as the sides. If A and B are the sides, C is the angle in between those 2 sides. Okay, so it would have been the 90-degree angle because we're treating C as though it were like a fake hypotenuse. That means that angle C would be the fake 90-degree angle. So that's why we're taking cosine of that, because it's the one that's we're treating as though it were 90 degrees, even though it's not. So there are 3 versions of the law of cosines. If you remember this pattern, you don't ever need to memorize all 3 versions. However, if you like to memorize things, if that's your mode of working in math, let's do the other 2 just in case. So if I treat B as the hypotenuse, that would be A squared plus C squared minus 2 times something times the cosine of something else. The first thing would be one of the sides. The second thing would be the other side. And the cosine would be the angle in between those 2 sides. So between A and C happens to be angle B. And to check, B and B. That's correct. And if I treated A as the hypotenuse, that means B squared plus C squared minus 2 times something times the cosine of something. The first thing would be B. That's one of the things we pretend is a side. The other one is C. That's something that we pretended was the other side. And the thing in between B and C is angle A. And to check, A and A. So those are your three versions of the law of cosines, but I strongly recommend that you just learn the pattern and then you can rewrite these however you want. So let's look at a homework question. Let me pull one up. Oh, that's a law of sines that we just did. Let me pull up a law of cosines. And again, on the exam, you won't know which one is which, so let's take a look and see if we can figure out which is which here. So I know that A is 47 degrees. I know that side B is 38. And I know that side C is 14. So I have an angle, side, angle. I do not know an angle and an opposite side. There's no way I could find it. So since I don't know an angle and an opposite side, I'm thinking, okay, law of cosines. And sure enough, angle side to angle is one of the ones we use law of cosines for. So the angle I know is 47, so I'm going to treat little a as my hypotenuse. I'm going to treat the 14 and the 38 as my two sides. If you have options for the hypotenuse, then use the longest side. So in a side, I would use the longest side as the hypotenuse. In theory, it works any other way, but if you use the longest side as the hypotenuse first in your law of cosines, it just makes the rest of your work go a lot easier. So side A, I'm treating as my hypotenuse. That's going to be the square of the two sides, the two other sides, minus 2 times the product of the two other sides, times the cosine of the angle in between them, which is 47. And so a squared is going to be, oh, there's no way I'm doing this in my head. Well, especially because there's a cosine in it. I'm still in degrees, and the question's in degrees, so we're good. 14 squared plus 38 squared minus 2 times 14 times 38 times cosine of 47 degrees. And what am I getting here? I'm getting 914. That just doesn't seem right. So let me double check this. Oh, that's a squared. Let me try that again. A 14 squared plus 38 squared minus 2 times 14 times 38 times cosine of 47 degrees is 914.3537. So I'll square root both sides, and of course we only need the positive square root. And that gives me 30.238. And again, we want 4 decimal places. So 23828, so 2383. There's my small a. Okay. Now, once I've got that side, let me write that in another color so we know we didn't have it originally. Now I can use law of sines because I have an angle and an opposite side. So I'm going to jump to law of sines in this case because it's just going to be a lot easier to work with. So sine of 47 degrees divided by my 30.2383 equals sine of B divided by 38, or you could do sine of C divided by 14. It doesn't matter. 38 times sine 47 divided by 30.2383 equals sine of B. So I'm going to take the inverse sign of that horrible, messy stuff. We all used tables when I was in school. We didn't have calculators to do this. And candy bars cost a nickel, I know. Okay, so inverse sine of 38 times sine 47. Notice that all of this is inside the sine, the arc sine, divided by 30.2383. And that's given me a 66.7921 for B. Okay, so my intermediate computations are at least 4. My answers are going to be the nearest tenth. And now I can get angle C. Since I know two angles, I won't even use the law of sines. Now I'll go to the fact that all three angles add up to 180. So 47 plus 66.7921 plus angle C equals 180. And I'll calculate that out. And that gives me 66.2079. So let's check those out too. Alex gave me 66.8, 66.2, and 30.2. What did we have? 66.8, 66.2, and 30.2. It's an ambiguous case.